The moon is Earth's silent companion, a world that moves with us through space, shaping our tides, influencing our climate, and reflecting sunlight into the night. It has been our closest cosmic neighbor for over 4 billion years. Though small compared to Earth, its presence has left a deep mark on our planet, on life, and on human imagination. The moon formed about 4.5 billion years ago, shortly after Earth itself. The most widely accepted explanation is the giant impact hypothesis. According to this idea, a young planet roughly the size of Mars collided with the early Earth. The tremendous force of the impact threw molten rock and debris into orbit. Over time, that material gathered, cooled, and became the moon. Chemical analysis of lunar rocks returned by astronauts shows a strong similarity to Earth's crust, supporting this shared origin. The moon is, in a sense, made from the same material as our own world. One of the strangest and most beautiful facts about the moon is that it always shows us the same face. This is because the moon is tidally locked. Its rotation period matches its orbit around Earth, so one side constantly faces us while the far side is forever turned away. This state didn't happen instantly. Over millions of years, Earth's gravity slowed the moon's rotation until the two became perfectly synchronized. Today, we see the same familiar patterns of craters and dark plains every night, while the hidden far side remained unknown until spacecraft mapped it. As the moon moves around Earth, the angle of sunlight hitting its surface changes, creating the phases that we see. When the moon is between Earth and the sun, its sunlit side faces away from us, and we see a thin sliver, or nothing at all, a new moon. As it continues its orbit, more of its illuminated side becomes visible, forming crescents, the first quarter, and then the full moon when Earth is between the moon and the sun. These phases repeat in a cycle that lasts about 29.5 days. Ancient cultures used this cycle to track time long before modern calendars were born. The gravitational pull between Earth and the moon shapes life in ways we still depend on today. The moon's gravity pulls on our oceans, causing the tides to rise and fall. Without the moon, tides would be smaller and slower, changing the way coastlines formed and affecting marine life that depends on tidal cycles. The moon also helps stabilize Earth's tilt. Without that influence, our climate would shift more wildly over time. Seasons might be harsher, and long-term habitability could be very different. Though it hangs far above us, the moon plays a crucial role in making Earth what it is. The moon orbits Earth at an average distance of about 384,000 kilometers, but that distance isn't constant. Its path is slightly elliptical, so at its closest point, perigee, the moon appears a little larger and brighter, often called a supermoon. At its farthest point, apogee, it looks slightly smaller, sometimes called a micromoon. Our calendars also create special names. A blue moon usually refers to the second full moon occurring within a single calendar month, and a harvest moon is the full moon closest to the autumn equinox, which rises earlier and appears brighter for several nights in a row. The moon can also look orange or red, especially near the horizon, because its light travels through thicker layers of Earth's atmosphere, which scatter blue wavelengths and let the warm colors pass through. Throughout history, the moon has also influenced the rhythm of human life. Many early calendars were based on its phases, marking months as the moon grew bright and faded again. Farmers once planted crops according to lunar cycles, believing that certain phases increased growth, harvest strength, or soil moisture. Even today, some studies suggest that humans may sleep slightly differently under a bright full moon, though this effect is still debated. Whether through tradition, science, or subtle biological responses, the moon's changing light has long served as a guide to time, seasons, and human behavior. Sometimes, the moon passes directly into Earth's shadow, creating a lunar eclipse. During these events, sunlight is blocked from reaching the moon, but Earth's atmosphere bends a small amount of red light around the edges, casting a copper or blood-red glow on the lunar surface. Lunar eclipses were once seen as omens, but today they are predictable and understood as elegant demonstrations of celestial alignment, Earth, Sun, and Moon all positioned in a straight line. The moon's surface tells its history in scars. Unlike Earth, it has no wind, water, or weather to erase impact marks. Craters from ancient collisions remain almost perfectly preserved. The dark, smooth areas called maria are ancient lava plains that filled deep basins long ago. Because nothing erases them, the moon's surface is a record of our solar system's violent past. Some regions are over 4 billion years old, making the moon one of the best windows into early planetary history. Many of the moon's features can be recognized with the naked eye. The large, dark plains, known as maria, were once thought to be seas. Mare Imbrium, Mare Tranquillitatis, and Oceanus Procellarum are among the most prominent, created long ago when lava filled giant impact basins. The bright highlands surrounding them are older, heavily cratered regions. Some of the moon's most famous craters include Tycho, with its striking rays that spread across the southern hemisphere, and Copernicus, a large, well-defined crater that stands out even through small telescopes. These features help scientists study the moon's age, composition, and the history of collisions in the early solar system. The moon is far smaller and less dense than Earth, which means its gravity is only about 1/6 as strong. An astronaut weighing 90 kilograms on Earth would weigh just 15 on the moon. This lower gravity affects everything. Dust drifts differently, footsteps land in long arcs, and objects fall more slowly. With gravity so weak, the moon cannot hold on to a thick atmosphere, which is why it remains airless and exposed to space. This lack of atmosphere leaves its surface unprotected from meteor impacts and radiation, but it also preserves footprints, tire tracks, and instruments that would have vanished long ago on Earth. Every mark made on the moon is a reminder that low gravity can freeze moments in time for millions of years. The far side of the moon, hidden from Earth, was a mystery for all of human history, until spacecraft revealed it in the 1960s. Instead of familiar dark plains, the far side is more rugged, covered in even more craters, with almost no maria at all. Scientists believe this difference is connected to the moon's internal structure and the way heat moved through it early in its formation. The far side reminds us how much we still have to learn about our nearest neighbor. Despite being a dry, airless world, the moon does contain water, not in oceans, but as ice frozen in deep, permanently shadowed craters near its poles. Temperatures in those places are so cold that ice can remain untouched for billions of years. Finding ice on the moon is important because it could be used someday for drinking water, for breathable oxygen, and even split into hydrogen and oxygen to make rocket fuel. Lunar ice may one day support explorers far from Earth. No story of the moon is complete without the Apollo missions. Between 1968 and 1972, astronauts orbited and walked on the lunar surface, collecting samples, measuring radiation, and studying geology firsthand. Footprints left in the lunar dust are still there today, unchanged, because there is no wind to erase them. These missions confirmed the Moon's origin, mapped its terrain, and gave us a physical connection to another world. The Apollo era still stands as one of humanity's greatest journeys. Today, attention has returned to the Moon. NASA's Artemis program aims to land astronauts on the lunar surface again, explore the South Pole, and begin preparing for long-term presence. Other space agencies and private companies are studying lunar bases that could serve as fuel stations, laboratories, or stepping stones for missions to Mars. The Moon may become humanity's first home beyond Earth, a place to learn, experiment, and build a new chapter in exploration. The Moon is also more active than it first seems. Sensitive instruments left behind by Apollo astronauts detected moonquakes. Small tremors that shake the lunar crust. Some quakes are caused by the cooling and shrinking of the Moon, while others result from tidal stretching as Earth's gravity tugs on it. These subtle tremors reveal that the Moon is not completely still, but continues to change and evolve over time. Deep beneath its surface, the Moon has a layered interior. Scientists believe it has a crust, a mantle, and a small core that may be partly molten. Unlike Earth, the Moon has no global magnetic field, but tiny traces of magnetism are found in lunar rocks, evidence that long ago its core may have been more active. Moonquakes reveal structural stress still present inside, but overall, the Moon is far quieter and more stable than Earth. Understanding its interior helps scientists compare it to other rocky worlds and learn more about how planets and moons formed in the early solar system. Though close in the sky, the Moon remains a world of its own. Its formation ties it to Earth, but its history, geology, and future exploration remind us that it is a separate place, ancient and enduring. It has shaped our tides, our calendars, our stories, and our dreams. It reflects sunlight into our nights and stabilizes our days. And as we learn more about it, the Moon continues to teach us about Earth, about the solar system, and about ourselves. Thank you for watching. A like and subscription to Real Space Stories helps the channel grow. I hope to see you in the next video.